Alright, so quiz for question number 2. So the question goes, based on the following reaction scheme, draw structural formula of P and T and give reagents Q, R and S. Okay, so let's start with P first. So here we have an aldehyde, because here we can see that, here we have CHO. Okay, so if you draw it, it will look like this. I would advise you to draw, okay, so that you can see how the structure looks like clearly. Okay, not just knowing the functional group. Alright, and then we're going to look at the reagent. We can see that this is an ozone followed by zinc in water. So this is ozonolysis reaction. That means that this is a reaction of alkene. Okay, so P will surely be an alkene. Okay, so this alkene will undergo bond cleavage right here, and then it will get double bond O lah. Okay, alright, so this is a retrosynthesis type of question, where we need to reverse from your product to your reactant. So what is the reactant that is used to get this aldehyde? Alright, so here we have 1, 2, 3, 4 carbons for this aldehyde. That means that your alkene must have 1, 2, 3, 4 carbons and then double bond, okay, here, and then it should have another 4 carbons, 1, 2, 3, 4, right? Okay, so when it cleaves here, you should get this aldehyde with only one aldehyde, okay, at the end. Okay, so let's say if any of you are confused between this answer and this answer, okay, why is it not cyclic, miss? Because if you have cyclic, okay, then you will get 2 aldehyde groups, because it cuts here and it is connected to each other, right? And another thing is that, let's say kalau dia 4 lah kan, okay, number of carbons dia still dapat sama, but it has 2 aldehyde groups. Dia akan dapat 2 double bond OH. Okay, unlike this one, because it is open, okay, dia bukan it is an open chain, it is not cyclic, then it will only get 1 double bond O. Okay, alright, so this one is the answer for P. Okay, and then we're going to look at T. Okay, so T is when your aldehyde reacts with, what is this, NH2OH in the presence of H plus your concentrated acid. Okay, concentrated acid. So actually this concentrated acid is a hint for an elimination reaction. Okay, and that means that you will be eliminating a small compound, right? So we have your big compound and big compound here, large compounds, aldehyde and is it amine, okay, with OH. So there is actually a condensation reaction. So when these two are condensed, you will be eliminating water. So how will it look like? You will be removing, okay, your oxygen from here, and actually the H2 from your amine here. Okay, so you will be removing this one, H2 and oxygen. Okay, and then you're just going to connect this double bond with this nitrogen. Okay, so you can look at the answer scheme at the back later. Okay, so next is we are going to give reagents Q, R and S. Alright, so here we have our aldehyde. So if you go to the left, you get a primary alcohol, and you should notice that the number of carbons, 1, 2, 3, 4, are still the same, 1, 2, 3, 4. If you go to the right, you get carboxylic acid, 1, 2, 3, 4, still the same number of carbons. Okay, that means that you're going to look at your functional group saja lah. So here we have CHO, okay, double bond OH, and then here we have double bond O, OH. Okay, double bond O, OH. And here we have 1, 2, 3, 4, and then carbon OH. Alright, alcohol. So let's go to the left first. What is happening here? How do we get primary alcohol? So your aldehyde, what does it undergo? Okay, you have C double bond O, and then suddenly you have OH only. That means your oxygen, it undergoes, is it R or O? Reduction or oxidation? If it gains hydrogen, that means it undergoes reduction. Okay, so this is the reduction of aldehyde. So awak kena tahulah what reducing agents that you can use for aldehyde. Okay, so if we go to the right, we get COOH. If you notice that you will be gaining oxygen right here, right? Daripada sini, sekarang awak ada oxygen. That means you are undergoing oxidation. Jadi, what oxidizing agent that you can use, okay, to get your carboxylic acid? So you have to know that, okay? Okay, last sekali, what is S? So here we have our aldehyde. Now we have 1, 2, 3, 4. And then we have a branch, a methyl group here, right here. And then OH. Okay, so if you notice, okay, this one here, 1, 2, 3, 4, OH. Okay, so this one comes from your aldehyde. Okay, it comes from your aldehyde. And where does this extra carbon come from? Okay, you have an addition of 1 carbon. It can only mean 2 things, whether you use nitrile or you use Grignard reagent, MGBR. Okay, so in this case, since we have aldehyde, okay, so it must have been Grignard reagent. Okay, so what is your Grignard reagent? Okay, it will be CH3MGBR. Why is that so? Because it means that this part here, okay, we know that this is delta positive and this is delta negative. And at your aldehyde, you have delta plus and delta negative. So the opposites will attract. This carbon will attach to this carbon on your aldehyde right here. Okay, and then don't forget that you have OH here already. So that means that this oxygen right here, okay, is being reduced. So you will be having hydrolysis as the second step. Alright, so first step is reaction with your Grignard reagent. Okay, second step is followed by hydrolysis. Okay, so that is question 2 for quiz 4.